So this is E3.2, which is polynomial division. We're going to go over long division and also synthetic division. Okay. For polynomial long division, sometimes we get a remainder and sometimes we don't. Okay. If we don't get a remainder, then that means that the divisor is a factor of the polynomial. Then the divisor is a factor of the polynomial. Okay, if there is a remainder, then the divisor is not a factor. Okay, then the divisor is not a factor of the polynomial. Okay, which makes sense, right? If it goes in evenly, then it's a factor. If there's a remainder, meaning there was a leftover piece, it didn't go in evenly, which would make it not a factor. Okay, so this is our division algorithm. It says let p of x and d of x be polynomials such that d of x is not 0 and the degree of d is less than or equal to the degree of p. Then there's unique polynomials q of x and r of x, which we call the quotient and the remainder, such that p of x is equal to q of x times d of x plus r of x. So what this is saying is if we have, let's say we don't have a remainder. Let's pretend that's not there. If I take this d of x and I take p of x and I divide it by d of x and it goes in evenly, this is just saying q of x, or our quotient, is our other factor. So we're really just trying to figure out what polynomial times the polynomial they gave me will give me my original polynomial. Okay. Now, if it doesn't go in evenly, that means that we can still find a quotient. We can still find a polynomial times our divisor that gets close to our original, but we're going to be off by a little bit. And that little bit that we're off by is called our remainder. Okay, so this is how we're going to write it out. And I'm just going to go ahead and put here, p of x is our dividend. Okay, q of x is our quotient. D of x is our divisor, and r of x is our remainder. So when we look at polynomial long division, remember we do our divisor, we divide that into our dividend, okay, and that gives us our quotient up here. Okay. And then when we work it out, sometimes we'll be left with a 0, which means we don't have a remainder. If we get anything else, then whatever's down here is our remainder. Okay. So let's go ahead and work some out. I want you to go ahead and divide these. I'm going to go over the long division process again, and then when we get our answer, we're going to write it in this form. Okay. We're going to write our original divisor, the quotient that we found, and the remainder that we found, unless our remainder is 0, and then we won't write it. Okay, okay. So let's go ahead and work this one out. If I have x squared minus 4x plus 4 is my divisor, I'm going to go ahead and write x squared minus 4x plus 4, and I'm dividing that into my original polynomial, which is my dividend, x cubed minus 6x squared plus 12x minus 10. I have 3 terms out here, so I'm going to move over 3 places, and I'm going to write my first number here. Okay, and I'm looking for what do I need to do to x squared to make it look like x cubed? I need to multiply it by 1x. So I'm going to do x times my divisor out here and write it under here. So I'm just going to write that out of here. I'm going to do x times x squared minus 4x plus 4. And whatever that equals, I'm going to write here. Now you don't have to write out this part that's in pink. I'm just doing it to show each step more elaborately. Okay. So x times x squared is x cubed. X times negative 4x is negative 4x squared, and x times 4 is positive 4x. Now remember, anytime we do long division, once we multiply it out, then we subtract what we got. Okay. Here I'm not going to say subtract since we have 3 terms. I'm going to say draw my line, change my signs. So this one becomes negative, this one becomes positive, this one becomes negative. Okay, and then I just combine down. So x cubed and x cubed cancel. Negative 6 and positive 4 leaves me with negative 2x squared. 12 minus 4 gives me positive 8x. And then I bring down the other term. Since my divisor has 3 terms, whatever I'm dividing it into needs to have at least 3 terms. Okay, and then I just start the process again. So I look at my x squared, which is my leading term, and I'm trying to make my leading term look like this leading term. So I need to multiply x squared by negative 2 in order for it to look like negative 2x. So I'm going to write over here, I'm going to do negative 2 times my entire divisor. And whatever that equals, I'm going to stick it here. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x gives me positive 8x. Okay. And negative 2 times negative 4 gives me negative 8. I draw my line and change my signs. So this one becomes positive, my second one becomes negative, my third one becomes positive. Okay. And then I just combine down. So when I combine down, my x squareds cancel, my 8x and negative 8x cancel, and notice all I'm left with is negative 2. So this right here is my remainder. Okay, this up here is my quotient. And then my two originals are my d of x. This is my d of x. And my divisor is my p of x. Okay, so I just want to rewrite my answer. Okay, so we know that p of x is the same thing as my divisor, which they gave us, which was x squared minus 4x plus 4, times the quotient that we figured out, which is what I did here in pink, so x minus 2, plus my remainder. So plus my remainder, which was negative 2. Now I'm going to leave it like that. On an exam, you could just change this. Instead of plus negative 2, you could just put minus 2. But in my math lab, they write your answer like this, and then you type in your answer for this and your answer for this. So make sure if you get a negative remainder, you go ahead and type in that negative with your answer. Okay? All right. So in other words, this is my d of x times my q of x plus my remainder, which is r of x. Okay, so that's how I want to write these when I'm done. So let's go ahead and look at another one, get a little bit more practice. For this one, same thing. I write my divisor out, which is 9x squared minus x minus 1. I'm dividing that into 9x to the 5th minus 10x to the 4th plus 18x cubed minus 28x squared plus x plus 3. Whew! So I have 3 terms of my divisor, so I'm going to move over 3 places and write my first number up here. Okay. So in pink, I look at my leading term, which is 9x squared. How can I make it look like this leading term, which is 9x to the 5th? So I already have the 9. I already have 2 x's, so I need x cubed. So x cubed times my divisor is what I'm going to do. And I'm going to go ahead and write it over here. X cubed times 9x squared minus x minus 1, and then write it here. So x cubed times x squared, 9x squared gives me 9x to the 5th. X cubed times negative x gives me negative x to the 4th. And x cubed times negative 1 gives me negative x cubed. Okay. Remember, I draw my line and change my sign. So it becomes negative 9, positive x to the 4th, positive x cubed. And then I combine down. When I combine down, my 9x's to the 5th cancel, and I'm left with negative 9x to the 4th plus 19x cubed minus 28x squared. And then I start the process over again. So I look at my leading term, which is 9x squared, and I look at the leading term I want it to look like, which is negative 9x to the 4th. So I need to change my 9 to negative. So that means I need a negative 1, or just a negative. And to go from x squared x to the 4th, I need to multiply by x squared. So I'm going to do negative x squared times my divisor and write it here. So negative x squared times 9x squared gives me negative 9x to the 4th. Negative x squared times negative x is positive x cubed. And negative x squared times negative 1 is positive x squared. Again, I draw my line, change my signs, this becomes positive, negative, negative, and then I combine down. So my 9x to the fourth cancel, and I'm left with 18x cubed minus 27x squared. Oh, I'm sorry, 29, because they're both negative. 29. And then I bring down my next term, which is plus x. Okay, and then I start the process again. I want my leading term, 9x squared, to become 18x cubed, which means I need to multiply by 2 and by x. So if I multiply 2x times my divisor here, 9x squared minus x minus 1, I'm going to write that here, which gives me 18x cubed minus 2x squared minus 2x. Then I draw my line, change my signs, which makes them negative, positive, positive, and I combine down. So my 18x cubes cancel, and I'm left with negative 27x squared plus 3x. Okay, and then I bring down my last term, which is plus 3. One more time, I look at my leading term, which is 9x squared, and I want it to look like negative 27x squared. So I just need to multiply by negative 3. So I'm going to do negative 3 times my divisor, which is 9x squared minus x minus 1, and write that here. So negative 3 times 9x squared is negative 27x squared. Negative 3 times x is positive 3x. Negative 3 times negative 1 is positive 3. I draw my line, change all my signs so they become positive, negative, negative. And notice when I combine down, everything cancels out, right? If everything cancels out, I'm left with a 0. Okay, so this is my q of x up here. This is my quotient. This is my r of x because this is my remainder. So if I write this one, my original p of x is my polynomial here on top. That's my dividend. It's the same as my divisor, which is 9x squared minus x minus 1 times the quotient that we found, which here is x cubed minus x squared plus 2x, so I need a little bit more room, minus 3, okay, plus my remainder, which here my remainder was 0. I'm going to go ahead and write it because y'all will have to enter it in my math lab. Okay, not too bad maybe. Okay, let's look at another one. On this next one, I don't have a lot of room. I'm going to have to write small. Okay, I'm going to go ahead and put in my divisor, which is x plus 3, and I'm dividing that into 5x to the 6th plus 15x to the 5th. Now notice I am missing an x to the 4th, and I am missing an x term. So I'm going to put in 0x to the 4th, and I'm going to put in 0x because I need a placeholder for each of those. Okay? So I'm going to go ahead and write in plus 0x to the 4th minus 2x cubed. Ooh, I need more room. Let me scoot this over. X plus 3 into 5x to the 6th plus 15x to the 5th plus 0x to the 4th minus 2x cubed minus 6x squared plus 0x plus 4. Goodness. So I have two terms out here, so I'm going to move over 2 places. My first number goes here. Okay. So what do I have to do to x to make it look like 5x to the 6th? I need to multiply by 5, and I need to multiply by x to the 5th. So I'm going to distribute that to my divisor. Now I'm not going to write the little cheater out here. Just know we're multiplying this times each term of the divisor and then writing it under here. So 5x to the 5th times x gives me 5x to the 6th. 5x to the 5th times 3 gives me positive 15x to the 5th. Okay? I draw my line, change my signs, and notice both things cancel out. So if both things cancel out, remember I have to have as many terms down here as I do in my divisor. So that means I need to bring down at least 2 more. Now since my next one is a 0, I'm not going to use that one. I'm going to bring down these 2. So I have negative 2x cubed minus 6x squared. Okay? And then I start the process again. So what do I need to multiply my x term by to make it look like negative 2x cubed? And I need to multiply by negative 2x squared. So now I'm going to distribute this negative 2x squared times each of these and write it below here. So negative 2x squared times x is negative 2x cubed. Negative 2x squared times 3 is negative 6x squared. And then I draw my line, change my signs, and notice the same thing happens again. So if they all cancel out, remember I have to have at least 2 terms down here. The next one is 0, so I don't want to use that. So when I bring down this next one, notice it's just a 4. So I don't have at least 2 terms. There's nothing I can multiply this x by to give me 4, so I'm done. That 4 is just going to be my remainder. So that means that my original p of x function is the same as the divisor they gave me, which is x plus 3, times the quotient that I got, which was 5x to the 5th minus 2x squared, okay, plus my remainder, which was 4. Okay. Remember, anytime you get a remainder, that means that this divisor is not a factor. So on the last problem, remember we got a remainder of 0. That one was a factor. Okay, so note to self. Okay, so there's one here for y'all to try. I'll give you a minute and then we'll go over it, okay? All right, so on this first practice problem, we went ahead and divided it out. Notice here on top of your quotient, you should have got negative 2x squared plus 4x minus 1. Now, I went ahead and wrote my remainder as a fraction here. If you didn't do that, don't worry about it, okay? That's how we used to teach it. Certain books still have you write it that way, but for the sake of this class, they're gonna have you write out your p of x function, and they're gonna have you write they're gonna give you the divisor d of x times q of x plus r of x, okay? And you're gonna have to enter your answer for q of x and for r of x. So I just went ahead and wrote out what you should have got for your quotient, which is your answer from the top, and your remainder, which in this case we don't write as a fraction. So I'm going to leave it like just 5. Our remainder here should have been 5. Okay. Okay, when we look at this second one, same thing, we do our long division. Again, if you did not write the remainder as a fraction, that's fine. That's not how my math lab has you enter it, so just ignore that. Okay, here your quotient should have been 3x cubed plus 4x minus 6. That should have been the answer you got on top, and it didn't go in evenly. We had a remainder of 13. Okay, so we go ahead and put our remainder in. Everybody okay? All right, let's keep going. This next topic we want to look at is how to use synthetic division, which is by far way easier than long division if we can use it. Now, specifically, we can only use synthetic division when we're dividing by polynomials that are in the form x minus k, or some textbooks use x minus c. It doesn't matter. Basically, k is a constant, c is a constant, whatever letter they use. So if you're dividing by a 2-term binomial where x is the highest power, just x to the first, plus or minus some constant, okay? Now, when we use a polynomial of the form x minus k, because we're not doing long division, I actually want to know what the solution is. Remember when we went over the other sections and we talked about using the solution form versus the factored form versus the x-intercept form? Okay, when we do synthetic division, we use the solution form. So if I were to set x minus k equal to 0 and solve, notice I would get x equals k. So when we use synthetic division, we're actually going to use positive k here. So if in your factored quantity you have x minus k, then you would plug k in. If you have x plus k, you would plug negative k in because we use the solved form. Okay, so let's go ahead and just do some. And they're much easier to explain as we do them than it is to explain and then do it. So the first thing I want to do is look at my divisor here and write it in solved form. So if I have x minus 2 equals 0, I would move that 2 over, which makes it positive. So I'm going to use a positive 2. And we put it in this little half box. And then we write out all the coefficients of our dividend, or of our original polynomial. Okay, so I'm going to write out -2, 8, -9, and 7. And I'm going to leave room, leave a space, and then draw a line. Now, remember, when we write out our coefficients, if you're missing any coefficients, you have to put in a 0 placeholder, just like you do with long division. Okay. Now, with synthetic, the first thing you do is always bring down your leading coefficient and write it below the line. Then we're going to multiply what's in our box times that number below the line. So 2 times -2 is -4. That's what I'm going to write under the 8. And then I combine straight down. 8 minus 4 is 4. And then again, I take the number in my box, which is 2, times that 4, which is 8. Okay? And then I combine straight down. -9 and 8 is -1. Then I take the number in my box, which is 2, times -1, which is -2, and I combine straight down, which is 5. Okay, so that's the gist of synthetic division. Now you just have to know what each piece means. Okay, whenever you have it written out like this, you start at the right side and work your way left. This last number that you entered, the 5, this is your remainder. Okay, this is your R of X. Excuse me. Okay, this next number over is your ones unit. So I'm just going to put, this is your, I guess, x to the 0 power. Then you move over, this is x to the first power. Okay, and this is your x squared. Okay, so notice as you move out, this tells you your polynomial. So this is the same thing. This piece gives you your quotient, or your q of x, and this gives you your remainder. Okay, so here our quotient, or the answer we would have gotten on top of our long division house, is -2x squared plus 4x minus 1. Okay, and our remainder is 5. Okay, so a little bit easier, you just have to remember what the numbers stand for. Okay, let's look at another one. First thing I do is solve the divisor. So this is x plus 3 equals 0. When I move the 3 over, that makes it negative. So I'm going to put -3 in my little half box, and I'm going to write out all the coefficients of my dividend, which is my original polynomial. So 3x to the 8th, 9x to the 7th. Okay, notice I don't have an x to the 6th. I don't have an x to the 5th. I don't have an x to the 4th. I have an x cubed, its coefficient is -1. I have an x squared, its coefficient is -3. I have an x, its coefficient is 1, and my units is a -1. Ooh, so that was a big one, right? Now I want to go ahead and bring my first number down. I do the number in my box, which is -3 times the number below my line. So -3 times 3 is -9. I combine down and get 0. Then I multiply that 0 by the number in my box. So 0 times -3 is 0. I combine down, I get 0. 0 times the -3 in my box is, again, 0. I combine down, I get 0. 0 times the -3 in my box is 0. I combine down, I get 0. 0 times the -3 in my box is still 0. This time when I combine down, I get -1. -1 times the 3 in my box is +3. I combine down, I get 0. 0 times the -3 in my box is 0. I combine down, I get 1. 1 times the -3 in my box is -3. So my last number when I combine down is -4. Okay, so I'm going to go ahead and write out here what we have. So this is my R of X, this is my remainder, this is my ones digit, okay, this is my X, this is my X squared, this is my X cubed, my X to the 4th, my X to the 5th, my X to the 6th, my X to the 7th. Okay, so this whole piece right here is my Q of X, and then my remainder is that last number. So I'm going to go ahead and write it out. Now when you write it out, if you have zeros, you don't have to write those terms out. Okay, so this means that my Q of X is equal to 3x to the 7th minus x squared plus 1. And my remainder, my R of X, is -4. So I just leave it like that. Okay, not too bad maybe. Synthetic hopefully is kind of fun. Let me show you how we're going to use synthetic, and then I'll let you practice some. Okay. So if we look at this next page, we have what's called the remainder theorem. So it says if a number c is substituted for x in the polynomial f of x, then the result is f of c. So basically we're plugging c into our function. F of c is the remainder that would be obtained by dividing f of x by x minus c. That is, if f of x is equal to x minus c times our quotient plus our remainder, then f of c equals r. What this means in a nutshell, let me go back up here. What this means is if this was some function, let's call this f of x, okay? If this was our function, if I take this value that we used in our box and I plug it into the function, so if I were to do f of -3, that equals my remainder. Okay, so if I plug -3 into my function, here it should equal -4, because -4 is this number that I got for my remainder. Okay, so it's a neat idea of if I want to evaluate some function and I don't maybe have a calculator or don't know how to use my calculator, you can always do synthetic division, and whatever your remainder value is, that's the value you would get when you plug that number into f, or into your function. Okay, now why we care? The reason we care is we know that if our remainder is 0, then that divisor, right, is a factor. So we use this to determine if the value of c is going to be a 0 of the polynomial, or in other words, if that divisor is a factor. Okay, so if we get a 0 remainder, then we know that that value of c is a 0 for the polynomial. Okay, so going back to our synonymous statements of if it's a 0, then it's a root. If it's a root, then it's a factor. If it's a factor, then it's a solution. Okay, so all related. So let's go ahead and look at these. Here it says use synthetic division to determine if the given value of c is a 0 of the polynomial. If not, determine f of c. So I'm going to go ahead and put, it already has it solved here, c. I used k earlier, same thing. So I'm going to go ahead and put 1/3 in my box, and I'm going to write out my coefficients, which are 12, -7, -32, -7, and 6. Notice I wasn't missing any terms. I had x to the 4th, x to the 3rd, x squared, x, and a constant term. If you're missing any of those, including the constant, you have to put a 0 in. Okay. I bring my 12 down and I do 12 times the number in my box. So if I do 12 times 1/3, right, that's 12 over 3, which is just 4. So I put 4 up here. -7 and 4 leaves me with -3. So now I'm going to do -3 times 1/3, which is -3/3, which is just -1. So I put -1 up here. -32 minus 1 is -33. So now I'm going to do -33 times 1/3, which gives me -33/3, which is -11. So I put -11 up here, combine down, I get -18. So if I do -18 times 1/3, I get -18/3, which is -6. So I put -6 here, combine down, I get a 0. Okay, so this is what I'm looking for. Okay, notice here my remainder is equal to 0. Okay, so that means that f of the number I plugged in here, f of 1/3 equals 0. So that means that this value is a 0 of this polynomial function, okay, or of this f of x. Excuse me. So this tells me, excuse me. So my answer here would be that f of 1/3 equals 0. So c, well, I don't want to say, so c is a 0. So 1/3 is a 0 of f of x. Okay. So as long as you get a 0 remainder, then that value of c is a 0. Okay. Let's look at another one. Same idea, they're giving you the c value. We're just trying to determine if it is a zero of the function. And the way we tell is if it has a zero remainder. So I'm going to put -2 in my box. I'm going to write out my coefficients. Notice I have a cubed, I have a squared, I have an x, and I have a constant. So I don't need to put in any zeros. So I'm just going to write out the numbers as they appear. Leave space, bring the first one down. 3 times -2 is -6. Combine down, I get -19. Excuse me. -19 times 2 gives me +38. When I combine down, that leaves me with 10. 10 times -2 is -20. And when I combine down, I'm left with -8. So notice here, this is not 0. Not 0. So what this is telling me is that when I plug -2 into this function, f of -2 equals -8. So -2 is not a zero of f of x. Okay, it's not a zero. Okay. All right, let me look at a couple more and then I will have y'all try a few. Okay, this one I'm going to put 3 in my box. When I put 3 in my box, I write out my coefficients. Notice I'm missing. I don't have an x cubed and I don't have an x, so I need to put in zeros. So I have 5, 0, -42, 0, -7. If you don't put those zeros in, you're not going to get the right answer. So I bring down my 5, which is 5. 5 times 3 gives me 15. When I combine down, that gives me 15. 15 times 3 gives me 45, which when I combine down leaves me with 3. 3 times 3 is 9. I combine down, I get 9. 9 times 3 is 27. I combine down, I get 20. So again here, okay, my remainder is not 0. Okay, if it's not 0, then that means that my c value is not a 0 of f of x. So we know that f of 3 is equal to 20, and that means that 3 is not a solution to f of x. Okay, or it's not a 0, however you want to write that. Okay. All right, let me look at one more that has a complex number, and then y'all can do some. So on this first one, I'm going to put 4i. Now remember with i's, I squared is -1. Otherwise, we just leave regular I to the first power alone. I'm going to write out my coefficients. I don't have any missing terms, so I have a 1, I have a -4, I have a 4, I have a -16. Okay? So I bring the 1 down. 1 times 4i is 4i. Now, -4 and 4i, I can't combine. Right? They're not like terms. So I'm just going to leave this as -4 plus 4i. So down here, I need to distribute that to what's in my box. So if I do 4i times -4 plus 4i, and I distribute, I get -16i times 16i squared. And remember, I squared is -1. So this is the same as 16 times -1, which gives me -16i minus 16. So that's what I'm going to write up here. So I have -16i minus 16. And when I combine down, I can combine my 4 and my -16. So I have -16i minus 12, right? Excuse me. And then I'm going to distribute my 4i to that. I'm going to use a different color. So I have 4i from my box times -16i minus 12. When I distribute, I get -56i minus 48i squared. Okay? So I have -56i minus 48 times -1, because that's what I squared equals. So I have -56i plus 48 is what I'm going to write up here. So, and I'm going to write it in the reverse order. 48 minus 56i. When I combine down, I can combine my -16 and my 48, which is going to give me 32 minus 56i. So notice what I ended up here with is not 0. Okay, it's not equal to 0. So this tells me that f of 4i is equal to 32 minus 56i, which means that c is not a 0 of this function. Okay, because my remainder was not 0 tells me that my c value is not a 0 of this function. All right. Okay, so there are 3 for y'all to try, and then we'll go over them in just a minute. Okay? Okay, so on this first one, we put 3 in our box, write out our coefficients, we're not missing any, and when we complete our synthetic division, we get a 0, which means our remainder is 0, which means the value of c, which is 3, is a 0 of this function. Okay? F of 3 equals 0, therefore 3 is a 0 of f. Okay? On the second one, same idea. I put 1 in my box. I write out my coefficients. Notice we're missing an x cubed and an x squared. So make sure you put those zeros in. When we do our synthetic, we end up with a remainder of 12, which means that, not f, this should not be a p. This means that f evaluated at 1 equals 12, which means it's not a 0. So I just put no. On number 3, okay, same idea. I put I in my little box, and when I carry out my synthetic, there's a little bit extra work. Make sure you know that I squared is -1, so make sure you're simplifying each step. When I work it all out, I get a 0 for a remainder, which means that f of I equals 0, which means that yes, I is a 0 of the f function. Okay, so that's the end of section 3.2. So you should now be able to complete that homework assignment on My Math Lab. There's no worksheet, just the 3.2 lesson. If you have any questions, please let me know. I'd be happy to help.